Welcome to Unit 2, the Media of Art, Lesson 14, Architecture. Architecture is the art of shaping space. Presented in this lesson is a brief history of the engineering and creative innovations that have affected architecture over the centuries. Some of the modern structures we'll be looking at also have some of the contemporary environmental concerns applied to their design. The objectives for this lesson are to consider the function of architecture to record and reflect a culture's values, explain the need for architects to combine function, form, and structure, identify traditional materials and methods used in architecture, describe the relationship of technological innovations to change in architectural forms and structure, recognize the impact of contemporary environmental concerns on architecture. The topics we'll be covering: an art and a science, traditional materials and methods, wood, stone, and brick, dry masonry, post and beam, round arch, vault and dome, pointed arch and vault, truss and balloon frame, modern materials and methods, cast iron, steel, and reinforced concrete, recent innovations, designing with nature, and contemporary approaches. In modern times, we have the advantage of houses being on the market for you to purchase to move in and live in. You can also possibly hire an architect to build yourself a house, or you yourself can also be a designer and construct yourself a house. But throughout time, mankind really has not had that luxury. At a certain point in history, mankind would have had to create a shelter such as this. This is a dolmen. This is the north of Carnac, France. It's a very, very old human construction that'll follow something we'll be looking at a little closely called post and lintel or post and beam construction, similar to something that you would have seen at Stonehenge, where there's some supporting stones with a larger stone that goes across. This is, of course, a little different in the sense that it has more surrounding stones. It's meant to be shelter and cover from the elements. So we will now begin our adventure into the styles, materials, and methods of architecture. When stones are piled on top of each other, and there is a consistent pattern involved as a result of that, it is called masonry. Dry masonry is when the stones are supported by their own weight when they're on top of each other, and you don't need any mortar to hold the stones together. This slide is of an architectural plan. We'll be looking at several of these as we examine different types of architecture in this lesson. This particular plan is for the Great Zimbabwe from Zimbabwe, Africa. It is a structure we're about to look at. So this is the actual Great Zimbabwe from Zimbabwe, Africa. It's the interior of the structure. It's created before 1450. This is a dry masonry structure. There is no mortar between the stones. The stones are laid out a little bit larger of a pattern on the bottom, and as they stack and go up in height, it tapers off towards the top, meaning that the area of the top of the wall is thinner than the bottom. It's easier to support the weight that way. The Great Zimbabwe is the largest ancient stone structure in Africa, south of the pyramids. The next method is post and beam construction, which is also known as post and lintel construction. Think of it as a more refined and simplified version of what was going on in the dolmen structure that we looked at the beginning of this lesson. In this slide, we have two examples of post and beam construction. Post and beam construction is one of the oldest building systems in the world. As a matter of fact, most of the world's existing architecture uses some form of post and beam construction. It's essentially two vertical supports or columns that have a horizontal beam across the top. This carries the weight down to the ground, thus giving the structure support. The colonnade and court of Amenhotep III in Egypt from almost 3,400 years ago is an example of post and beam or post and lintel construction. You have your vertical supports that are columns in this case with horizontal beams across the top. A row of columns connected with horizontal beams is called a colonnade. The next architectural methods are round arch, vault, and dome. So first we're going to review our arches and their extensions thereof. With the invention of the round arch, it solved some of the weight support issues that come with the post and beam construction system. It can't support a lot of load from the top, so the round arch solve some of those issues. It's not the most perfect system. These systems eventually evolve as well, as we'll be going over in a few slides. When constructing an arch, there's a support system that holds the stones that are basically forming the vertical supports in place for support until the wedge pieces come to the final point where there's only space for one left. That's where the keystone goes in. That basically keeps everything together, allows the wooden supports to be taken away. That's for the round arch. A barrel vault is when you get a series of round arches in a row. They form a tunnel-like structure. A groin vault is an evolution that was expanded upon with the Romans. A groin vault is the intersection of two barrel vaults. In the lower right-hand corner, we have an arcade, which is a series of arches supported by columns. Also, these support structures for arches are called piers sometimes as well. Pont du Gard in Nimes, France, is almost 2,000 years old. It is a structure built by the Romans that is called an aqueduct. It was for the transportation of water to different locations, kind of primitive plumbing before it went seriously underground. This structure is a series of arches and arcades, and most of these are really not standing in many other locations. They spanned long distances and didn't have the support of these mountainous areas like we have in this particular case. Now we move on to the domes. A dome is an arch rotated 180 degrees. An example of that's in the upper left-hand corner. In the upper right-hand corner, you have an example of a dome on a cylinder. And on the bottom in the middle, you have a dome on pendentives. Pendentives are the triangular, curvy support structures that rest below the dome. This slide is of the Hagia Sophia. It was originally built as a Byzantine cathedral in Istanbul, Turkey. The basic structure of this is a dome on pendentives. Eventually, other portions were added to the structure. On the left and the right, you have minarets, which are the pointy little towers. These were added, and the Hagia Sophia was converted to a mosque after the Islamic conquest in the mid-1400s. Nowadays, the Hagia Sophia is a museum. This slide is of the interior of the Hagia Sophia. Back when this was built, of course, there was no electricity, and they had to figure out a way to get light inside the building. So when it was designed, there's little arch systems that create little windows at the top and on the sides. You can also see this unusual perspective of the pendentives from the inside. That's the support structure. There was an immense amount of weight to hold up. The next methods we'll be looking at are elaborations off of the arch system. We have the pointed arch and vault. This slide is of the interior of the Notre Dame Cathedral in Chartres, France. It was built between 1145 and 1513. The pointed arch and vault are strongly associated with Gothic architecture. You will also see the pointed arch referred to as the Gothic arch. A barrel vault, so to say, made of these Gothic arches is a pointed vault. The Gothic arch allowed these architectural structures to be built on a massive scale. They, of course, also came with their problems. They had to be supported with the support structures on the outside called buttresses, and the more elaborate large ones for giant structures were called flying buttresses. In this slide we have two diagrams. In the upper left is a diagram of the Gothic arch. You can see how this is a variation off of the original arch system. There really is no center keystone here. We have the two wedges that come together to form the point. In the lower right hand corner you have the large buttresses, which are called flying buttresses, the support system to hold the immense structures up that were built with these Gothic arch and vault systems. The next architectural methods we'll be going over are truss and balloon frame construction. In the upper left-hand corner of this slide we have examples of trusses. Trusses are triangular frameworks that are used to span or to support. In the lower right-hand corner we have a diagram of a balloon frame construction. Balloon frames were expanded versions of the original trusses with modern manufacturing during the 19th century. After the Industrial Revolution, the large timbers were replaced with thinner studs. Also, nails were being manufactured by this point, and it was easier to construct these systems with these newer technologies. Cast iron is the next architectural method we'll be going over. Cast iron is a direct result of the Industrial Revolution, where smelting processes were perfected and large factories were being built. If you look at this grouping of words, cast and iron, cast is taken from casting, which we went over in lesson 10 on sculpture. Remember, a mold is made. In this case, iron is melted and poured into that mold. This way, any of the iron beams, columns, screws, nails, whatever needed to be used could be manufactured in large amounts. The Crystal Palace from Joseph Paxton, that was in London for the Great Exhibition of the Works of Industry of All Nations, existed only from 1850 to 1851. It was meant to be temporary and to show the potential of iron. It only took 6 months to construct the Crystal Palace. It was definitely an exhibition of the potential of what new industrial technologies could do. When you think in modern times of iron, it seems extremely heavy and cumbersome. It was eventually replaced with steel products, but back in the time it was a revolutionary concept in architecture. Steel and reinforced concrete is the next architectural method. Steel and reinforced concrete allowed for taller structures to be built on an even quicker scale than with iron, and it is still used in most construction today. There are a few other methods that have evolved since then, and we'll be looking at those towards the end of the lesson. One term you'll be hearing more often in the upcoming lessons is school. School is not meant to mean a building or structure that people go to get educated. It is actually meant to be a school of thought. This can be spanned across painting and other medium, and we'll be talking about that in later lessons. The leader of the Chicago school was architect Louis Sullivan. If he wouldn't have designed the Wainwright Building in St. Louis, Missouri, we would not have the modern skyscraper today. This was the original influence and idea which they built upon to get larger and taller with structures. This is actually unique to America originally. We came up with the idea. Steel and reinforced concrete made the skyscrapers possible, and also elevators helped with the people who were supposed to be inside ascend the levels at a much quicker pace than they would have had to with stairs. French architect and designer Le Corbusier designed the domino construction system, which allowed larger skyscrapers to have larger open spaces and open windows not blocked by columns and structures. Here you basically have 6 vertical supports and concrete slabs that are supported by those Concrete slabs also by this point have a lot of rebar in them, which is a webbing made of steel that also helps with the support of the concrete. Le Corbusier's design for the domino construction system was part of the international style movement in architecture. This coincided with the times of what was going on in art, where things were being simplified down to harmonious elements. International style structures were intended to express the function of the building. International style led to Bauhaus. This is a structure by Walter Gropius. That's the exterior. It was built between 1926 and 1927. Germany was the location for the Bauhaus movement. A lot of those ideas did spread to other places, but you look at the international style as the kind of blanket overall that there was modern movements all over the world at this time that were kind of following this simplification of structures. The general public, especially in America, was a little bit slow to take to the international style. I would say it probably rose in America to its importance a little bit more in the 1950s, but in the late 1920s, early 1930s, we have the Art Deco style, which is a decorative style that pays a little bit tribute to C-forms and certain abstractions thereof. That might be a little bit general in a sense for describing Art Deco, but it is a very decorative for the sake of decoration, but very reserved and streamlined. That was going to be applied to architecture as we see in the Crest building from 1935 in this slide. This slide is of the skyscraper that is the Seagram building in New York. It was built between 1956 and 1958. Architects Ludwig Mies van der Rohe and Philip Johnson were responsible for designing this building. Van der Rohe had conceived of tall skyscrapers like this way back all the way to 1919, but it wasn't until this time period in the 50s, with the perfection of steel frame construction, that buildings like this were able to be built. Also, he had a very famous statement about these type of structures that less is more. This slide is just a diagram of steel frame construction. Just gives you a view of what it would look like underneath all of the glass and concrete. We're now going to get into some more recent innovations in architecture, pretty much starting in the early 1960s. The invention of the shell structure and the suspension structure allowed architects and engineers to design and build larger and more expansive structures that also could defy gravity somehow with their shapes, as we see in the upper left-hand corner with a shell structure designed for the TWA terminal at the JFK airport in New York. It was built between 1956 and 1962. The architect Eero Saarinen also was the architect who worked in collaboration on the Gateway Arch in St. Louis. In the lower right-hand corner, we have an example of a suspension structure that's commonly used on bridges and in some architectural designs. This is the Jeppesen Terminal Building at the Denver International Airport in Colorado. It was built in 1994. This is the world's largest suspension structure. The roof is basically a giant tent made of over 15 acres of woven fiberglass. It also has a Teflon coating on top. This design was initially inspired by the Rocky Mountains that would be seen at various times of the day off in the distance. This is the Guggenheim Museum Bilbao in Bilbao, Spain. It was constructed in 1997. He calls the design for this a metallic flower. It's a sort of functional sculpture. With the 3D program, he's allowed to push and pull the design, but still hold it within certain physics principles so that it doesn't collapse on itself. Some modern architects are switching over to carbon fiber for their structures. Carbon fiber is very durable, very lightweight, and very strong. What we have in the slide is the BMW Guggenheim Lab, which is an open-air carbon fiber structure in Berlin, Germany. This is so lightweight that one person can actually carry the components for this building. Prefabricated structures, or portions thereof, seem to be a modern trend that came out of Europe. It is taking on here in America, especially in big cities like San Francisco and New York. Most of the time, because in these big cities you have to come in and out pretty quickly. This building that we see here was built within a week. It's the Alex Monroe Jewelry Store in London. In this slide we have the three examples of shaping a building from extant architecture. This is in your forming art section of the architecture chapter in your text. I'm not going to spend a lot of time going over this necessarily. It's a little bit of a focus on this company and their attitudes towards modern design and architecture. This is a little bit more of an architects group where the architects work as a unit together rather than what can happen in a lot of architecture firms that are dominated by one single mind. The last aspect of architecture we will be discussing is designing with nature. A leading proponent of designing with nature, and probably the most important architect of the 20th century, was Frank Lloyd Wright. This is his Edgar Kaufman residence called Falling Water. It's in Bear Run, Pennsylvania. It was built in 1936. This structure wasn't intended to be blended in with nature. It was supposed to be in harmony with nature in its design. You can actually see that there's a little bit of a waterfall that comes off of one of the porch areas on the bottom. This was designed with wide open flowing spaces on the interiors. This was a revolution in architecture that spread throughout modern design in America. Designing with nature in modern times can also be green building. Green building is basically when a building or structure has the least impact possible on its local environment. This particular structure for the Gish family apartments in San Jose, California, won several awards for its design. It's got solar panels, recycled materials for the carpeted floors. It also has the best available energy efficient appliances, and the lumber was harvested in a sustainable fashion. The Museum of Contemporary Art in Denver, Colorado is also green in its conceptualization. It was built on top of a repurposed, cleaned up hazardous waste site. It also uses radiant heating in floors. There is no ductwork with a heating system like an air conditioner. And the cooling system for the structure is an evaporative cooler rather than an air conditioning unit, which conserves energy and no freon is used. This is also a green architecture design. It's by architect Michelle Kaufman. It's the MK Solaire home from 2008. This has something that's been common in Europe for a while, but on-demand features, meaning that you can turn a water heater on when you need to use it, or any other type of heating or cooling device. This is also a modern concept in design, that this is a prefabricated house that can be laid out in any particular fashion, sticking to the design on the land the purchaser so desires. Here in this slide we have the Aqua Tower, built in 2010. This is a modern day energy efficient skyscraper. The actual shape, the outer parts of the building, you can look at it and they have kind of this ribbed surface to it. This actually helps with the impact of the wind on the building. Most buildings do have some type of allowance for sway due to this outer design of the structure. It actually helps lessen the impact of that on the structure. Also, to keep the energy efficiency aspect going, there is heat resistant glass to actually help quite a bit with the air conditioning aspect of the building. Many other green applications were also used in this to keep it kind of in the modern terms of trying to be more harmonious with the environment. This was the last slide of our lecture on architecture. Thank you very much for listening.